We're going to kick off with our finance lessons, and starting off from tomorrow. The thing is, the purpose of this presentation is for us to avoid wasting a lot of time focusing on the basic calculation. So what I want you to remember is that in grade 11, we used to perform calculations which are based on some once off. You just put the money in the account and then it starts growing, or you buy something and when you pay it back you just do it once. Unfortunately, when it comes to this particular part of your learning stage, which is grade 12, we also look at what we call annuities, or the payments or the deposits will be recurring. So that is basically what we'll be looking at tomorrow. Tonight I just want us to look at just a reminder, okay, as to what is it that we do in the finance lessons, in the finance calculations, which is very important foundation, because even in your exam you're going to find these things waiting for you. All right, let us look at the growth engines, and let us look at the simple versus the compound interest. So I just want to start off with simple and compound interest. Simple and compound interest. Okay. So right now, when we are looking at these, here is something. I'm just going to draw a horizontal line here. Oh, that's a horizontal line. Now, let's talk about how money grows. Remember, from grade 11, we had two growth models. Namely, we also had simple interest and we also had compound interest. So I'm just going to call it simple int. So simple interest, we the formula was A is equal to P 1 plus IN. This is the formula that we use for simple interest. And then compound interest, I'm just going to call it comp int. Then compound interest would say A is equal to P 1 plus I to the power of n. Now the thing is, you don't need to worry about, my god, how am I going to remember all these things? Fortunately, you will find these formulas at the end of every question paper that you will be putting your hands on when it comes to your metric. Alright, so now what I want us to understand is that simple interest, it simply grows linearly. Okay, if you look at it, I want us to look at it like this. If we are having, let's say maybe you started off with a certain amount of money, it steadily increases but in a straight line way. Okay, so basically something like that. As time goes on, so let us say this is the accumulated amount and this is the time, maybe in years or something. So it increases like that. And what I want you to understand is, maybe to remind you, is that you earn an amount that is the same on each and every year. That is basically the original amount as the starting principal. So all right, so we can have a situation where we would say, let's say maybe you have, let me just show you an exemplar question here. So we have Andrew. So we have this guy, Andrew. Maybe I'm just gonna have to type this on because I think it's faster that way. So we have Andrew, who is actually going to invest. Andrew invests 17,000 rand. So what amount will you have after 9 years? What amount will his money grow to in 9 years time? If the interest is calculated, say at 14% per annum, simple interest. Okay, so that is the situation, and now we are saying, well, how much will he gain? So what we are looking at here, the key to this is that we are looking at a situation where Andrew, this dude, he is in a situation of investment, and he's here's the data to the information that we have. We actually are looking at this guy, and he's having he's starting off with the starting amount, the principal amount is equal to 17,000 rand. That's quite a huge amount, and his money and the time of investment is 9 years, and it is they just said per annum and simple interest. So our n is simply 9, and they said if the interest is calculated of 14%, so if you say 14 over 100, it gives us 0.14 simple interest. So they said simple interest, so the formula for simple interest, we're saying A is equal to what? For the accumulated amount, the amount that will be accumulated, it is equal to the principal amount 1 plus IN. Now that is the most important thing. The next thing that we just do is to simply plug out these values, right? So 17,000, 1 plus 0.14 times 9. So if you plug out on that, if you plug out those items, you find what? Alright, let me use my calculator quickly. I just need to fetch it. Alright, so this is what we have. We're looking at 17,000 into 1 plus 0.14. We're multiplying it by 9. This gives us 38,420. So after 9 years, he's going to find 38,420 rand as an approximate in his account. However, without really considering the bank charges and other stuff. Alright, so basically this is it. This is what we're saying. Now the thing is, we're just substituting there. Let's look at compound interest. Now, if we look at compound interest is usually what happens in most of the cases. Now, basically in like the real world, it grows exponentially. Let me have a look. Let me just show you here. Now, when it comes to compound interest, it will grow exponentially. So compound interest accumulates faster compared to the simple interest. So compound interest can be good news or bad news, depending on the situation. If you are investing, wow, this is amazing. But if you're going to pay that money back, wow, that's pretty bad news. All right. So I want us to look at the very same situation, but now this time around, when this guy is, let's say, it's 14%. Andrew, we're still looking at Andrew, but this time around, let's maybe put it lower. Let's say 13%. Let's say 13%. That is the rate, and compounded monthly. Okay, let's say it is being compounded monthly. So what is really going to happen? What is really going to happen? We are saying, well, the principal amount is still the same, 17,000. Just gonna say 17k to save time, and the time is still 9 years, and it's 13%, so 0.13. And the time is 9, but the item said compounded monthly. So since it's compounded monthly, we're gonna have to multiply by 12 here and divide by 12 here. You need to remember that very well. Whenever we say compound, we have 12 months in a year. If it's compounded monthly, we divide by 12. If they say compounded annually, we divide by how many half years do we have in 1 year? We have 2, so we divide by 2 for the interest rate and the time. If the time is not given in, if the time is given in years, we have to multiply by 2. Sorry. So that is the thing that we are actually doing. If it's compounded quarterly, it means that the number of years you multiply by 4, then you divide the interest rate by 4. In this case, they said monthly, so we're going to multiply by 12 because of 12 months in 1 year, and we divide by 12 when it comes to the interest rate. Okay, it's something important for you to remember that. Then the next thing that we then do is to simply substitute and plug out into the formula. So we're saying A is equal to what? P 1 plus I raised to the power of n. So that is to say our P is 17,000. To save time, I'm just going to say times 10 to the power of 3. I'm still saying thousands, okay? 1 plus our interest rate is 0.13, and we are dividing by 12 here, raising it to the power of 9 times 12. So that is what we have. And if you plug out, I'm going to say 0.13 over 12. Then I'm going to raise this to the power of 9 times 12. This dude is going to accumulate a huge amount of 54,430 rand 0.31 cents. Okay, that's quite a huge amount compared to, because it's compound interest, it really accumulates really faster. Okay, so that is the thing, and that is what we're saying. Now the other thing is, please understand, let me just put this down so that you don't forget, right? Make sure, because we ain't gonna really be discussing stuff like this, it's for small children, once you understand it. So we're saying monthly, if they say interest is compounded monthly, we are saying I is equal to, let's just use 13%, right? 0.13 you divide by 12, and n will be equal to, let's say we're using that 9, you multiply by 12. If it's let's say quarterly, right, the most common, let's say they say it compounded quarterly, it means I will be equal to, I'm just gonna use the very same 13%, so I divide by 4, that n I then say 9 times 4. That is, please understand that I'm just using the example above to, that is why I'm using 9 here, okay? You don't have to always say 9, you just use the number of years that will be given there, if it is given in years. Sometimes we have half yearly, semi-annually, and for that we're saying I is equal to 0.13. How many half years do we have in a year? We have, how many months do we have in a year? How many half years do we have in a year? How many months when we say monthly? How many months? How many quarters do we have when we say quarterly? How many half years do we have when we say semi-annually? So we have 2 of them, right? And our n will be equal to 9 times 2. So that is basically what we do. Most of the times you find these ones. All right, now let us look at some decay engines. So what do we have? We actually have what we call straight line depreciation and reducing balance depreciation. So we have straight line depreciation. So we say the accumulated amount again is equal to P1 minus IN. Okay, so we for any form of depreciation we are subtracting, and this is the first one. The second one that we have is the reducing balance method. Reducing balance method. Okay, so for the reducing balance method we are talking about compound decay. So it's 1 minus I raised to the power of n. So that is what we are talking about here. Okay, that being said, I'm just going to move on to the other thing that I want us to appreciate is that when it comes to straight line, they are this amount is fixed, right? The assets will be losing value at a fixed amount every other year. The money that will be it's going to be the same. Okay, let us say maybe if you say we got a dude let's look at an example question. Let's say we're having it I'm just let me type it again because I know this is gonna take time. Let me bring it here. Okay, cool. Just do it there. Okay, let's say we have equipment that is worth 40,000. It's worth 40,000 rand, depreciates at 16%. Per annum. What will the equipment be in 4 years' time if the calculation in 4 years time? If calculation is done using the straight line method. So that will be the situation. So we're saying, well, how much will this equipment cost when it keeps on losing its value just like that over the period of 4 years? So what is the data that we have? Well, we are looking at the starting value, the principal amount. The starting value is 40k. Okay, so there we go. I'm just gonna call it 40k right here. And then the interest rate I is equal to 0.16. Then n is equal to 4. We're looking at 4 years, and then we're using what? Straight line method. So if we are looking at straight line method, we're saying the accumulated amount is equal to P1 minus IN. In this case, our P is 40,000. I'm just going to say times 10 to the power of 3 to save my, so that this thing cannot take advantage of too much misbehavior. Alright, so that's the thing, and 1 minus Ri is 0.16 times 4. So if we plug out, well, don't worry about many brackets because your calculator will automatically respect the rules, the precedence rules of operations. Alright, so if you take that and perform the calculations, what are we having here? With a situation, it's 40k into 1 minus 0.16 times 4, that's 14,400 rand. So that's 14,400 rand. Okay, so that's if we're using straight line method. What about if we are using the reducing balance method? Let's say the same, using reducing balance method. Let's see if this is going to be nice. Let's say we are using the reducing balance method. Let's say the question says using reducing balance method, so we're going to say, well, the accumulated amount will be equal to P1 minus I raised to the power of n. Okay, so it should therefore be, we had our 40,000 1 minus 0.16 raised to the power of 4. So if you plug out, you see that instead of it being 14,400, this one will write it here. 85 cents. Alright, so that is basically what is happening. That is basically what is happening here. Alright, so that is the other part which we basically discuss when it comes to these. Alright, well, I want to also talk about inflation. Inflation. Alright, now what I want you to understand about inflation is that it's just compound interest formula, okay? So when it comes to inflation, we're using the compound interest formula. Plus I to the power of n. So that is what we will be using. And say for the milk to raise from 8 rand 46 cents to 13 rand over the 10 years, you're just going to substitute all the values. Then if you want, let's say maybe we want to calculate the value of I, right? Let's say milk let's just say going from £8 46 to say 13 rand 99 cents, right? 13 rand 99 cents over the period of 10 years. What is the inflation rate? So we're saying the accumulated amount, the new amount, is now 13 rand 99 cents. It started at 8 rand 46 cents. 1 plus I, which we do not really know, over the period of 10 years. Then we just need to solve for I. So the first thing that we can do, we can say this implies that 13 rand 99 cents divided by 8 rand 46 cents is equal to 1 plus I raised to the power of 10. So there are many ways in which you can do this, including the introduction of the logarithms, if you like, or but here for me, since this 10 is over there, I'm going to do it like this. I will say to the power of 1 over 10 here and multiply by 1 over 10 over there, such that this will cancel, and then I'll end up with that particular number, 13.99 over 8 rand 46 cents to the power of 1 over 10 is equal to 1 plus I. Therefore I is equal to what? 13.99 divided by 8.46 raised to the power of 1 over 10. Then I move the 1 to the other side, becomes -1. If I plug out that, let's say 13.99 over 8.46 raised to the power of 1 over 10, then you say to the answer, you subtract a 1, you get the answer that you get from the calculator is 0.051 and 5, 8, etc., etc. So therefore I is equal to, you multiply that particular number by 100, you get 5.16 to 2 decimal places percent. Alright, so this becomes your final answer there. Now that is what we can say. That is what we can say when it comes to inflation. Now the other thing is, compound interest can also be applied to graphs. In a curved line, it represents an exponential growth, not a straight line, right? So if you want to pick your starting principal value at n equal to 0, and then you determine your final answer there. Now the other thing that I want us to also discuss as introductory is about the nominal rate. So I want us to look at the nominal versus effective interest rates. Nominal versus the effective interest rates. Alright, so the nominal rate is the stated annual rate, okay? Nominal So the nominal rate is basically the stated annual rate. Let's say 12%, say 12% per annum, that is compounded monthly. That is compounded monthly. So I want you to understand that this is the named rate. It's the named rate, but it doesn't show the true growth. Okay, so the other point, nominal, it does not show true growth. So it doesn't, okay? It doesn't show the true growth. So the effective rate is the actual real economic interest that is earned over the full year. So to jump between the two, effective, I'm just gonna point out effective here. When it comes to the effective, we're saying, well, that one is the actual. Okay, it is basically the actual, the real thing. So to jump between the two, or when it comes to conversion, I want you to now this formula, you might not really find it in the formula sheet. You can find it in textbooks, but when it comes to the final, you won't be given this one. So you need to do not confuse where the effective is written and where the nominal is. Okay, it's very important for you to familiarize yourself this particular formula. So that is what we're saying, that is the nominal here of m raised to the power of m. Okay, now what is the, let's say, what is the effective annual rate for 18%? Just move this. What is the effective annual rate for, say, 18%? Right? Say 18%. That is per annum compounded quarterly. I'm just going to say comp for compounded quarterly. So the annual, the yearly, right? So what do? We just, that is exactly what we want, since they said 18% quarterly. It's the effective, right? So if we want the annual, we're going to say 1 plus I effective. The effective is what we do not know, right? So I effective is equal to 1 plus the nominal. They said 18%, so I'm going to say 0.18. Then they said compounded what? Quarterly, so I'm going to divide by 4 and raise it to the power of 4. So basically that is what I'm doing when it comes to the conversion. So if you perform your calculations, you realize that your I effective is equal to 19.25%. Okay. We can perform the reverse. If you have 10% effective, and then you want to find the nominal, right? You can still do the same. Okay, you can just perform the reverse calculations, and 1 plus 0.10 is equal to 1 plus I nominal over 12 if we're talking about the monthly, and raise it to the power of 12. So if you perform your calculations, that is basically, so this is the conversion part. These are some of the questions you'd find, questions like these ones at the top there. So but I had to give you a baseline of this because it's very important. You definitely find questions like maybe carrying like 4 marks, and you cannot afford to lose those. My main concern tomorrow, the lesson is going to be focusing on calculating the